Hey everyone! Today we're going to dive into a really powerful technique that can take your code from slow and clunky to incredibly fast and elegant. It's called the sliding window. And it's not just an algorithm, it's a mental model that once you get it is going to totally change how you look at a whole class of programming problems. So let's just kick things off with a simple question, okay? Imagine you've got a list of numbers. Your job is to find the biggest possible sum you can get from any three numbers that are right next to each other. How would you do it? And more importantly, how would you do it without doing a ton of extra, unnecessary work? All right, so the first way you'd probably think to solve this is what we call the brute force approach. It's the intuitive path, the one that makes sense right away. And hey, it works, but it's hiding a huge inefficiency. So what does this brute force method actually do? Well, it's pretty straightforward. It looks at the first three numbers and adds them up. Got it. Then it moves over one spot and calculates the sum of the next three numbers, completely from scratch. It does this over and over for every single possible group, which means it's constantly re-adding the same numbers it just looked at a second ago. All of that recalculating? That is just wasted work. In computer science terms, we say this has a time complexity of O of n squared, or O of n squared. Just think of it like this. As your list gets bigger, this method gets exponentially slower. It just grinds to a halt. There has to be a better way, right? And of course there is. This is where our hero of the story comes in, the sliding window technique. This is the aha moment, the elegant solution that avoids all that wasted effort. And wow, when you put them side by side, the difference is just night and day. Brute force is O of n squared, slow, constantly recalculating everything from zero. The sliding window is O of n. We call that linear time. And it's fast because its whole philosophy is to reuse and update. It gets rid of all that duplicate work, which makes it a real game changer. So what is it really? At its heart, the sliding window is this super clever trick that takes a problem you'd normally solve with two loops nested inside each other and transforms it into one single efficient loop. That simple change is what drops the time complexity from quadratic all the way down to linear. That's what makes it so much faster on bigger datasets. That all sounds great in theory, but how does this thing actually work? How does the window slide? Let's make this abstract idea totally concrete and walk through our original problem step by step. Okay, let's do it. We start with our very first window. It contains the numbers 4, 2, and 1. We add them up, and the sum is 7. So for now, 7 is our maximum sum. Simple enough. Now, here's the magic. This is the whole point. To get the sum of our next group, we're not going to add up three new numbers. We're just going to slide the window one position to the right. And here's how we do it. We take our current sum, which is 7. We subtract the number that's leaving the window on the left, that's the 4. Then we add the new number that's entering on the right, that's a 7. And boom, our new sum is 10. Just one subtraction and one addition. And since 10 is bigger than 7, 10 is our new maximum. And that's literally it. We just keep repeating that simple process. Slide, subtract, add, and compare. We keep sliding and updating our maximum sum as we go until we've gone through the whole list. In this case, we'd eventually find our final answer is 16, and we did it all in one single, super efficient pass. Okay, so now that you get the basic mechanic, let's expand our toolkit a little bit. This technique actually comes in two main flavors that you'll see out in the world. First up is the fixed size window, which is what we just used. The size, well, it's fixed, it never changes. Think of it like a window on a train car, just moving steadily along the track. It's perfect for problems that say something specific, like find the max sum of a subarray of size k. But then you've also got the variable size window. This one is way more dynamic. It can actually grow and shrink to satisfy some kind of condition. That caterpillar analogy is perfect. It's inching along, changing its shape as it needs to. You use this when a problem asks for the longest or shortest something that meets a certain rule. Which brings us to probably the most important question of all. How do you know when to use this? What are the telltale signs of a sliding window problem when you see one out in the wild? Think of this as your cheat sheet. First, the problem is almost always going to involve something like a list, an array, or a string. It's going to ask for a contiguous subsequence. That means a piece that's unbroken. You really want to be on the lookout for keywords like longest, shortest,
minimum, or maximum. And if you see a really specific constraint, like, say, find the longest substring with no more than k distinct characters, that is a giant flashing neon sign that you should be thinking about a sliding window.
You know, in the end, the goal isn't just to learn this one little trick. As the programmer Ryan Shakti put it, we don't want to memorize an algorithm. We want to understand the mental model. The sliding window is more than just a piece of code. It's a new way of seeing problems. It's about recognizing wasted work and finding an elegant, efficient path. It's about shifting your entire thinking from brute force to reuse and flow.